Ocean waves and tides. If you were to picture the beach, you would probably picture crashing waves coming down on the sand. But where did those waves come from? Well, the process of wave formation begins with wind, and without the energy of the wind, there would be no waves. Most waves form when winds blowing across the water surface transmit their energy to the water. A wave is just that movement of energy through the water. It is not actually the water moving itself. Now, waves start in the open ocean, and their size depends on the strength of the wind, how long that wind has been blowing, and the distance over which the wind blows. When studying waves, scientists describe the size and strength of waves a little bit different than maybe a surfer or a sailor would. While ocean enthusiasts use terms such as combers, breakers, and spindrifts, scientists have terms for parts of the waves. The name for the highest part of the wave is the crest, while the lowest part of the wave is the trough. The distance from crest to crest or trough to trough is called a wavelength. The vertical distance from crest to crest, or the crest to the rest line, is amplitude, or the amount of energy a wave has. Waves are also measured by their frequency, or the number of times they pass a point in a second. Now, friction with ocean floor causes waves to slow down in shallow water near the shore, and depending on the energy of the wave and how long it traveled and its speed determines the wave height and how hard it comes crashing down. At first, the energy of a breaking wave causes the water to surge up on the beach, but gravity eventually pulls that water back down and it flows into the sea. And this is called surf. This is much different than tides. Tides are the daily rise and fall of Earth's water on its coastlines. As tides come in, the level of the water on the beach gradually rises, and when it reaches its highest point, it is referred to as its high tide. When the tide goes out and starts flowing back toward the sea, the water reaches its low point and is referred to as low tide. But unlike waves, tides happen regularly no matter how the wind blows or how much energy the waves have. Tides are caused by the interaction of Earth, the moon, and the sun. The moon's pull on Earth's water causes tidal bulges to form on the side closest to the moon and the side farthest from the moon. These bulges represent high tides along coastlines. As Earth turns completely around each day, people near the shore observe the rise and fall of the tides as they reach the area of each tidal bulge. In general, the high tides occur about every 12 hours and 25 minutes apart in each location. The sun is so massive that its gravity also affects the tides in the pole and pulls the water on Earth's surface towards it. Sometimes the moon and the sun pull together on Earth's water in the same direction, while other times they pull in different directions. Changes in the positions of Earth, the moon, and the sun affect the height of the tides during a month. Spring tides and neap tides are caused by the position of the Earth, the sun, and the moon. When the moon, sun, and the Earth are in a straight line, a spring tide occurs. These tides get their name not because they occur during the spring season, but from an old English word meaning to jump. Now, when the moon is at a right angle to the sun, a neap tide occurs. This occurs between spring tides at the first and third quarters of the moon. A neap tide is a tide with the least difference between low and high tide. Here's a diagram, and you can see when the moon and the sun and the Earth are in a straight line, the bulge occurs at the spring tide. Compared to that, when the moon is at a right angle to the sun, the sun's gravity pulls some of the water away from the tidal bulge facing the moon, and this acts to even out the water levels over Earth's surface, reducing the difference between the high and low tides. Okay, let's take a break here and show what you know.